Xilinx President and CEO, Victor Pengın.
Thank you. Good morning. Welcome to XDF 2019. So discovering the Higgs boson, sometimes modestly called the God particle, landing an autonomous rover on the surface of Mars, finding evidence of water on an asteroid 1.2 billion miles away. These are just some of the breakthroughs that innovators like all of you in this room are achieving with our products. So here on Earth, where most but not all CEOs reside, you're building applications in communications infrastructure, medical and life sciences, industrial application, transportation, and of course computing both in the cloud and the edge. It's incredibly exciting to see the intelligent connected world actually becoming a reality, and many of you in this audience are making that happen with our products and with our platforms. So you may have heard me talk about our strategy, and if you haven't, I'll just go through very quickly. Just three simple elements: data center first, accelerating growth in our core markets, and driving adaptive computing. Now, one of the ways I think about this strategy is that it's really all about empowering more hardware and software developers like you with our uniquely powerful and adaptable platform. We've made phenomenal progress since last year's XDF, and you're going to hear all about it today, and more importantly, you're going to see it throughout this forum. So I really encourage you, you'll hear me give some shout outs to some of the things that are out on the floor. So I'm going to really talk about what we've accomplished in the past year, as well as where we're headed. And I'm going to focus on markets that are going through some really significant transformations, and again, many of you are driving that transformation. And we expect that to be driving a lot of growth for Xilinx. So these growth drivers map directly to two of our three strategies. Obviously, data center maps directly to the data center first element of the strategy. 5G and automotive are two of our traditional core markets. We've participated in those markets for well over decades, and we really see that as tremendous growth. And the third element is driving adaptive computing, and we really see that getting momentum across all markets. Okay, so let me start with 5G infrastructure. Last year, as many of you know, South Korea led the world in deploying 5G base stations, and our 60-nanometer UltraScale Plus products were in those base stations. But instead of me going on and talking about the deployment of 5G, I'd like to bring on stage someone who is directly making that happen. So I'm delighted to welcome the Vice President and Head of Technology and Strategy at Samsung, Dr. Won-Il Roh.
Good morning. So,
all right, thank you. Yeah, good enough. So, last year we also talked about our continuing transformation of platforms, and that's when we first shared Versal, the Versal architecture, including the AI engine, which you heard Won-Il talk about, as well as the various product families. Since then, we've taped out Versal, and we've shipped those silicon to customers, and you'll hear more about that. Last year, we also unveiled the fact that we were launching the Alveo board business, right? So we had our very first PCIe acceleration card for data center. And today, we have 4 Alveo boards shipping in production based on UltraScale Plus. The first product was the U200. We followed up with a more powerful U250. And then we have the U280 that has integrated HBM as well as multiple DDR channels for the ultimate performance. Most recently, we announced a U50 that has integrated HBM, but in a half-height, half-length form factor. So really packing a lot of performance in a 75-watt kind of overall board budget. So really powerful lineup. Now, excited as we are about what we've done in the past year in Versal, in ACAP, Alveo, we're more excited about what we're doing in the ACAP products. So I'm going to show you, first I want to introduce to you what we believe is the most advanced processing chip ever made. It's 36 billion transistor, 7-nanometer Versal. So I know, last year it was PowerPoint, now we got the real goods. The second thing I want to show you is the first Versal PCI development board. Okay? So, in the past, as we just launched our Alveo business, we haven't really had development boards as rapid, but you can count on us moving forward that we will always have development boards as soon as we have silicon for new architecture, and of course we're going to have production boards as soon as we have production silicon. Alright, so I encourage you to check out applications running on these development boards. There are multiple of them in the concourse area. So this brings me to the next major market that we talked about driving growth, and that's data center. So last year at XDF, we were just launching that very first Alveo board, the U200, so of course we're just beginning to build an ecosystem, an ISV ecosystem, hardware and an ISV ecosystem around Alveo. So we made really great progress over the past year growing both of them. And we have major OEMs signed up like Dell, HP, and Innsbruck. We've also signed up major VARs and distributors like Colfax and Ingram. And on the software ecosystem front, we've brought a growing number of ISVs doing applications like video, data analytics, machine learning, health sciences, and finance. And of course, there's more developers. We've trained close to 6,000 developers over the past year, and we have over 700 accelerator partners in our accelerator program. There are 85 production applications now listed on the website between AWS's F1 and our Alveo ecosystem, and there are many more applications under development. So again, you can see some of these accelerated apps in the current Alveo out in the concourse area. So what I'd like to do now is to bring on stage key leaders from Amazon Web Services. And as you all know, Amazon was the first to have the vision of FPGA as a service and the first to roll out that offering. And they've been absolutely instrumental in the growth of accelerated applications based on FPGAs. So please give a very warm welcome to Senior Director of Business Development at AWS, Gadi Ut, and the Head of Engineering for Amazon Neo, Vin Sharma. Give it up for truly inspirational, right? So let me just give you a few more examples of what Xilinx compute acceleration can do compared to traditional computing on a CPU. Twitch team, we talked about it a bit last year, but Twitch team doing streaming video saw a 30x performance boost compared to running on just a regular CPU. Illumina, another leading life sciences company, saw a 90x increase on a genomics application. And 10 Insights, which is a home video security company, achieved a 100x performance boost on their application, which, by the way, includes AI acceleration. Okay, so, but as powerful as all this is, compute acceleration is not the only place where Xilinx plays in the data center. We also play in storage and networking. So let me cover storage first. So we've been working with partners like IBM, Micron, and Samsung who develop accelerated storage, memory, computational storage. This is where you're processing where the data resides. As we all know, data is absolutely exploding. It's growing at a continuous exponential, and so rapid database query response is absolutely critical. So our products can accelerate functions like compression and decompression, encryption. You can do other kinds of processing, dedupe, and so forth. And you can see performance gains of up to around 4x using a single accelerator in these devices. And we think that scales fairly linearly. Like if you see the graphic, if you add 4 more accelerators, you get about 13x. So that's really pretty cool. And again, this is being developed or deployed today. Moving on to networking, we play in SmartNICs, which the industry is just beginning to adopt, but really will be the way to go. SmartNICs provide better security by detecting and removing malicious packets, but also accelerates packet processing by offloading some of the network stack, or the network stack completely from the CPU to the SmartNIC. And that not only then relieves performance bottleneck to the data center, but it actually frees up the CPU now to do application execution, which improves the TCO. So I'll give you an example on a dual socket data center server. Data plane throughput gets accelerated about 3 to 6x. CPU utilization is increased by 1.5x, 50% with Xilinx-based SmartNICs. And again, because our silicon is programmable not only with silicon, but software, but also with hardware, we could really customize these solutions for optimal performance and as well as unique security needs that you might have in different deployments. And we could do that all with a single common board without changing silicon on the board. Okay, so I've talked about now compute acceleration, storage, and networking, and these are things that are already deployed or well under development. So that's what's happening today. So let me share with you how we see the future of data center. You know, the first to set up is this unrelenting demand for more compute and explosion of data. That's going to continue. So data centers of all kinds, particularly in the cloud, whether that's public cloud, private cloud, or a hybrid cloud, it's just going to continue to explode. So data center operators are absolutely looking to improve their utilization of their installed resources, improve the performance and the power efficiency, because obviously OpEx is huge, and that improves the overall TCO. So we have this term we call distributed adaptive computing, and we believe that you can achieve all of those key careabouts by disaggregating kind of all these resources into banks of CPUs with smart NICs, with FPGAs, or in the future certainly ACAPs, those computational storage devices, as well as, of course, compute accelerators. All that connected through network, traditional networks, and also maybe additional fabrics. So these resources can then be composed on demand to meet the needs of a specific workload running in your data center at that moment. So for instance, you know, control-intensive workloads that really need a lot of, you know, the CPU power, but at the same time has a lot of network intensity, you might want to provision that, you know, some more of those CPUs that have the smart NIC that does the offloading. Compute-intensive workloads like AI, which you just heard about, you might want to provision more of those compute acceleration resources, right? And then if you have data-intensive workloads for massive data sets, you'd obviously want to then provision more of these computational storage devices, right? So again, because our ACAPs can be optimized all the way down to the architectural level, not just at the software level, you can optimize for that specific workload that's being provisioned. And because ACAPs could be optimized dynamically, right, while it's running, you can get the benefit of hardware acceleration and very high utilization of all this distributed accelerators throughout, whether it's near the CPU, near the storage, or near the network. So what does this all mean? Distributed adaptive computing delivers the data center operators low TCO due to the dynamic optimization for workloads with acceleration and high utilization of all those accelerators in the data center. High performance and low latency, you heard that, right? So wherever you have this acceleration, not only do you have high throughput performance, but you have low latency, which is really important. And you can customize and rapidly deploy new innovations. That's what having, you know, this capability in the cloud is all about. As soon as you have maybe a new neural network, a new video codec, or whatever it is, a new way to optimize network pruning, you can quickly deploy it. You don't have to wait for new silicon or hardware. Okay, so we think that's a pretty compelling feature, but coming back to the present, the first stepping stone was just launching Alveo, and now you heard that we have a complete lineup of 16 nanometers with Verso coming in. What I'd like to do now is bring onto stage a senior technical leader for a company that's been driving the computing industry for decades. Right? They could talk about what they're doing with Alveo now. So I'm really thrilled to welcome to stage distinguished engineer at Microsoft Azure, Mela Raghuram.
Great to be here.
So thank you so much.
Thank you.
Yeah, thank you. Okay, so, you know, I covered a lot about the hardware aspect of our platform transformation, but platforms are both hardware and software, so let me talk about the software. You know, many years ago, actually approaching 10 years ago, we overhauled the very foundation of our entire software stack by introducing Vitisles, right? That was a clean sheet of paper, supporting hardware designers. It's really best in class for any kind of hardware development. But we've been layering things on top of that, and we'll continue to innovate in Vitisles. But as our products, our silicon architecture became more platform-centric with Zinc first and second generation, we started deploying more software around that for embedded developers with our runtime and our SDSoC environment. For data center deployments, we had our SDXL for deployments like F1, and now you hear from Azure. Now, most recently, we've also introduced a toolkit to accelerate AI inference, and you've heard about AI also, again, with SageMaker Neo. So now, our complete platforms, that's the silicon architectures, the boards with Alveo, and the software is very, very powerful, very, very complete. However, due to the evolution, right, we actually have different development environments. And, to reduce the complexity of multiple environments and to deliver a much cleaner, more productive user interface, we're going to be unifying all those environments into a single environment. So I'm incredibly excited after years and incredible amounts of investment to do this, to announce Vitis, a single development environment for applications whether IoT, edge devices, edge computing to the cloud, communications for all markets essentially. Okay, so Vitis is going to support those heterogeneous architecture we talked about. So our current Zinc, first and second generation, versatile ACAPs, of course. And the whole idea is that developers will get the productivity experience they're accustomed to in developing software. And the benefits is incredibly powerful hardware optimization without needing any hardware expertise. You heard many of the AWS customers don't know how to spell FPGA. And they're not interested in learning, by the way. Hardware optimizations can be as simple as a few critical kernels to accelerate things, but we could also be leveraging an entire domain-specific architecture, even particularly domain-specific languages. So Vitis will be available for general access at the end of this month. They'll be supporting our current products, and then of course we have already Vitis in early access for versatile ACAP. So this is a really simplified view of the stack. Going from bottom to top, of course, we start with our boards, and again, it could be Alveo boards for the data center, but it could also be some of our development boards for Zinc, for embedded applications. And then we have, of course, compilers, analyzing other tools, and we have a number of optimized libraries for different domains, and finally support for industry standard frameworks and perhaps DSAs as well. We're delivering 8 optimized libraries, including just a couple of things like computer vision, optimized linear algebra, quantitative finance. And we'll be adding more over time. Today we support frameworks like AI and video transcoding. And we also have partners that also support different frameworks, like Blacklink supports Elasticsearch. Now, right after my talk, Salil Rajay, EVP and GM of our data center group, he's going to give you more details about Vitis. But before he comes on, I get to give you share one more detail about Vitis that I think many of you as developers will like. Most developers tend to like this. It's free. It's free for all. Biggest applause so far. I guess it's not, whatever, we're not always associated with that, but free for all Xilinx boards, whether it's Alveo or embedded applications, and it's open. Right? So instead of our traditional proprietary IDE with managed projects and integrated text editor and so forth, which is very good, we've heard the feedback, Vitis plugs into standard software environments. So if you want, you could use non-standard code editors, makefile, revision control systems. Right? So free and open Vitis is a win for all of you developers, and based on the applause, I guess you appreciate that, and it's really integral to our strategy. So the other thing I want to emphasize is our commitment to open source. Many people really aren't aware that we've been an active user of open source since 2001, and actually quite an active contributor since 2007. In 2018, we were the #1 contributor to U-Boot, and we co-founded OpenAMP, which is around asymmetric multiprocessing with many other software firms, and we just recently spun that off last week on the Linaro Open Source Community Project. This year, we've made open source absolutely core to our software strategy. And that is why we're making Vitis open source standard plugins, standard frameworks, software development environments, and free. The Vitis runtime, the libraries, the AI models, they're all available today under Apache license. Okay, so free and open should definitely drive greater adoption of our platform in all markets, and of course, especially in some of these growth markets, particularly, of course, data center. So, Which brings me to the last of the markets, automotive. And this is clearly a market that everyone knows is undergoing tremendous transformation, huge disruption. And we see this as a very enormous long-term market opportunity for us and, of course, all of our customers and developers. So again, our customers can tell that story much better than I. So I'm delighted to introduce a leading supplier of automotive technology and an early adopter of both Versal as well as Vitis for ADAS and autonomous driving. Please give a warm welcome to Vice President of Hitachi Automotive Systems of the Americas, Hiroki Uchiyama-san. So as you can see, AI is being deployed in our cars, of course in the cloud, you heard that in both leading cloud providers, in our homes, in infrastructure, everywhere. Because our platform is being deployed from everything from cars and robots and infrastructure, grids, communications infrastructure, and data center, we're really uniquely positioned to drive AI proliferation. So we're introducing Vitis AI, which is a machine learning plugin to Vitis. So we'll be empowering AI data scientists with support for standard frameworks like TensorFlow. We're going to be delivering 30-plus optimized neural network models open source to GitHub. A development kit for network optimizations like quantization and so forth, compilers, and in fact, we'll be delivering some domain-specific architectures that will enable people to get compile times of minutes, in some cases even seconds, right? So AI development on this adaptable platform really is going to drive innovation in multiple markets. You know, innovation comes from many different places. Both F1 and Azure, that's enabled innovators around the planet in virtually every marketplace. We have innovation going in very large, leading customers, leading the industry, but also a resurgence of startups, very innovative startups, particularly in the area of AI and automotive. So I'm really excited to introduce my last guest, who is leading a very hot startup, and they're doing both, AI and autonomous vehicles. So please welcome CEO and co-founder of Pony AI, James Peng.
Thank you all.
Driving conditions in China if you've ever been there, so yeah, it's really awesome to see again, all these really advanced technologies running on our, and you hear some common themes, right? High performance, processing massive amounts of data, but still real time, low latency. You hear the criticality of how that works, literally life and death, and you hear that we can do sensor fusion as well as processing. Not too many solutions can do all those different things. So, I just want to wrap this up with my personal perspective on what this forum is really all about. I really love products and technologies, 37 years in the industry. I'm sure everybody in this room feels the same way. But it's not just because it's intellectually stimulating. It's because it's really a way to make the future better. Right? You've heard some really inspiring things, right? People accelerating genomic analysis for finding genomic targeted research cures for cancer. Helping people communicate better. Helping people live longer, healthier lives. Solving business problems. And helping people travel much more safely and more sustainably. I mean, those are really meaningful things. So you've heard about exactly those things, as well as people who are enabling more innovation to happen on this powerful platform, more of you to use it. And that's what we're passionate about. We're passionate about helping you. And that includes all of you who have never used our products before. And we're absolutely passionate because we want to help you make that better future happen soon. That's what's behind our transformation to platforms. That's why we did the Versal ACAP. That's why we're introducing Vitis AI, and that's why we've embraced open source. So I really hope you use this forum to learn more about our products and platforms, to see more amazing things customers and partners are doing, and then get out in the concourse, And hopefully that really inspires you to join us in building the intelligent, adaptable world together. Okay, thank you so much. Have a great forum.
Please welcome Xilinx Executive Vice President and General Manager,